When working with variable frequency drives, often referred to as VFD, there are a few key points to understand regarding wiring and motor selection. Firstly, concerning the initial question about shielded wiring, the documentation for the VFD most likely refers to shielding the power wiring between the VFD and the motor. The reason for this shielding is to minimize electromagnetic interference, or EMI. VFD work by rapidly switching power to the motor, and this high-frequency switching creates EMI. This EMI can disrupt nearby electronic equipment and cause interference in power lines. Shielding the power cables involves wrapping them in a conductive material. Common materials include aluminum foil or braided copper mesh. The shield must be grounded to the VFD enclosure. This provides a path for EMI currents to flow safely to ground, preventing them from radiating and causing interference. Without proper shielding, the high-frequency noise generated by the VFD can negatively affect other sensitive electronic equipment in the vicinity. Secondly, regarding the question about inverter-rated motors, it's important to recognize that these motors are specifically designed for use with VFD. Standard induction motors are not designed to withstand the stresses imposed by the high-frequency switching of VFD. Using a standard motor with a VFD can lead to several problems, including premature bearing failure, insulation breakdown, and other issues. Inverter-rated motors are constructed with different materials and techniques to mitigate these problems. They incorporate features such as reinforced insulation to withstand the high voltage spikes produced by VFD. They often have increased cooling capacity to deal with the additional heat generated by the VFD switching. They typically include features to reduce bearing currents, which are a common cause of bearing failure in motors driven by VFD. They may also have improved torque characteristics at low speeds, which is beneficial for applications where precise speed control is required. To summarize the differences between standard and inverter-rated motors, consider these points. 1. Reinforced insulation. Inverter-rated motors have enhanced insulation systems to handle the high voltage stresses from VFD. 2. Increased cooling capacity. These motors often feature larger fans or improved cooling designs to dissipate heat more effectively. 3. Reduced bearing currents. Inverter-rated motors incorporate features like insulated bearings or shaft grounding to minimize bearing currents. And 4. Improved torque characteristics. Some inverter-rated motors are designed to provide better torque performance at low speeds. It is strongly recommended to use an inverter-rated motor when connecting a VFD to a motor. Although it may be tempting to save money by using a standard motor, the long-term costs of premature failure and downtime can outweigh the initial savings. In summary, when installing a VFD, pay close attention to the manufacturer's recommendations regarding shielded wiring. Always ensure that the shield is properly grounded to the VFD enclosure. And, whenever possible, use an inverter-rated motor to ensure reliable and long-lasting operation. These practices will help to minimize EMI and prevent premature motor failure, resulting in a more robust and efficient system. Understanding these considerations is crucial for anyone working with VFD and motors, as it ensures proper operation and longevity of the equipment. Variable frequency drives are electronic devices used to control the speed of AC induction motors. They work by varying the frequency and voltage supplied to the motor, allowing for precise speed control and energy savings. VFD are commonly used in a wide range of applications, including pumps, fans, conveyors, and machine tools. The high-frequency switching of the VFD creates electromagnetic interference, which can disrupt the electronic equipment and cause problems with power quality. The shielding helps to contain this interference and prevent it from radiating outwards. Shielded cables are designed with a layer of conductive material, such as braided copper or aluminum foil, that surrounds the conductors carrying the power. The shield acts as a barrier to electromagnetic radiation, preventing it from escaping the cable. The shield is connected to ground, which provides a path for the interference currents to flow back to the source. This helps to minimize the amount of interference that is radiated into the surrounding environment. Grounding the shield is essential for its effectiveness. The shield must be connected to a good ground point, such as the VFD enclosure or a dedicated grounding electrode. This ensures that the interference currents have a low impedance path to flow back to the source. Without proper grounding, the shield can actually act as an antenna, radiating the interference instead of containing it. In addition to shielding the power cables, it is also important to shield any control cables that are connected to the VFD. Control cables can also carry interference, which can disrupt the operation of the VFD or other electronic equipment. Shielded control cables are similar to shielded power cables, with a layer of conductive material surrounding the conductors. The shield is connected to ground at both ends of the cable. Inverter-rated motors are designed to withstand the high-frequency switching of VFD. They have several features that make them more suitable for use with VFD than standard induction motors. One important feature is reinforced insulation. The insulation in inverter-rated motors is designed to withstand the high voltage spikes that are produced by VFD. These voltage spikes can damage the insulation in standard induction motors, leading to premature failure. Another important feature is increased cooling capacity. VFD can cause motors to run hotter than they would if they were powered directly from the AC line. Inverter-rated motors have larger fans or other cooling features to help dissipate this heat. This helps to prevent the motor from overheating and failing. Inverter-rated motors also have features to reduce bearing currents. Bearing currents are caused by the high-frequency switching of VFD. These currents can flow through the motor bearings, causing them to wear out prematurely. Inverter-rated motors have features such as insulated bearings or shaft grounding to minimize these currents. In addition to these features, inverter-rated motors may also have improved torque characteristics at low speeds. VFD can cause motors to lose torque at low speeds. Inverter-rated motors are designed to maintain their torque output even at low speeds. When selecting a motor for use with the VFD, it is important to choose an inverter-rated motor. Inverter-rated motors are more expensive than standard induction motors, but they will last longer and provide better performance. There are several factors to consider when selecting an inverter-rated motor. One factor is the motor's voltage rating. The motor's voltage rating must match the VFD output voltage. Another factor is the motor's horsepower rating. The motor's horsepower rating must be sufficient for the application. It is also important to consider the motor's speed rating. The motor's speed rating must be compatible with the VFD speed range. Finally, it is important to consider the motor's enclosure type. The enclosure type must be appropriate for the environment in which the motor will be used. In summary, when working with VFD, it is important to use shielded cables and inverter-rated motors. Shielded cables help to minimize electromagnetic interference, and inverter-rated motors are designed to withstand the high-frequency switching of VFD. By following these recommendations, you can ensure that your VFD system operates reliably and efficiently. The benefits of using a VFD include energy savings, precise speed control, and reduced mechanical stress on the motor and driven equipment. VFD can also improve process control and reduce downtime. The initial cost of a VFD can be offset by the energy savings and other benefits over time. Proper installation and maintenance are essential for ensuring the long-term reliability of a VFD system. This includes selecting the correct motor, using shielded cables, and grounding the system properly. Regular inspections and maintenance can help to identify and prevent potential problems. In conclusion, understanding the principles of VFD wiring and motor selection is crucial for anyone working with these systems. By following the recommendations outlined above, you can ensure that your VFD system operates safely, reliably, and efficiently. Variable frequency drives offer a versatile and effective method for controlling AC motors in a wide variety of industrial and commercial applications. However, to realize the full potential of a VFD system, it is vital to adhere to best practices for wiring and motor selection. Shielded cables play a critical role in mitigating electromagnetic interference, which can disrupt the operation of nearby electronic equipment. Inverter-rated motors are specifically designed to withstand the stresses imposed by VFD, ensuring long-term reliability and performance. By paying attention to these details, engineers and technicians can create robust and efficient VFD systems that deliver significant energy savings and improve process control. Furthermore, staying informed about the latest advancements in VFD technology and motor design is essential for optimizing system performance and minimizing downtime. Regularly consulting manufacturers' documentation and seeking expert advice can help to ensure that the VFD system is operating at its peak efficiency and providing the maximum return on investment. In addition to the technical aspects of VFD wiring and motor selection, it is also important to consider safety. VFD can operate at high voltages and currents, so it is essential to follow all safety precautions when working with these systems. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following lockout/tagout procedures when performing maintenance. By prioritizing safety, you can prevent accidents and injuries and ensure that the VFD system is operated in a safe and responsible manner. Ultimately, the success of a VFD system depends on the combination of technical expertise, attention to detail, and a commitment to safety. By mastering the principles of VFD wiring and motor selection, and by following best practices for installation, maintenance, and safety, you can unlock the full potential of this powerful technology and achieve significant benefits for your organization. The information above offers a comprehensive overview of the key considerations for VFD wiring and motor selection, providing valuable guidance for engineers, technicians, and anyone else who works with these systems. By applying these principles, you can ensure that your VFD system operates reliably, efficiently, and safely for years to come. Remember to always consult with qualified professionals and adhere to relevant codes and standards when working with electrical equipment. With careful planning and execution, you can harness the power of VFD technology to improve your operations and achieve your business goals.